We are going to demonstrate an example regarding a simple analog signal. For that, we have a water tank here and we want to check the fill rate of this tank. Or we have a pressure tank and we want to check the pressure. It depends on your needs. You can change the names in accordance with your needs. If the water level is above 90%, the high level signal. If it is below 10%, low level signal. And if it is between 10% and 90%, normal level signals will be lit. Just think of this as a pressure system, for example an energy generation system. Think of the pressured air tank in a power plant. Let's say the pressure value in the pressured air tank is normally 100%. I mean maximum pressure is 100 bars. Now 100 bar is the dangerous pressure. If the pressure is 90 bars, that pressure notifies the command room that your pressure is high. Let's say the pressure drops down. You will activate the system, for example, you will work with the generator or you will engage a system. Before engaging that, you have to check the pressured air system. Maybe when the system is offline, the pressure drops because of air leakage. Or the pressure can drop during revision periods. Before you engage the system, of course, you need to check these. Let's say your pressure here dropped below 10%. I mean it dropped below 10 bars and your command room or where your operator is based had received a low level signal. Let's assume your operation pressure is between 10 and 90 bars normally. This is a random number. Normally it won't be that high. Normally it's between 85 and 90 bars. But we will say 10 and 90 for the sake of this example. If there are a pressure level between 10 and 90 bars, which means your pressure is somewhere between 10% and 90%, a pressure level normal signal will be directed to where your operator is based or where your command center is based. And when you use an analog sensor in order to measure the level here, and here we will assume that sensor is a 0-10 watt sensor. Now folks, for that we have created a software, but before that I have to say this. We had to add another analog card here and that analog card had to have a feature that measures voltage. Look, our analog card here has to have a feature that measures voltage and you need to select your card accordingly. The card we picked can measure plus negative 10 volt. For example, it can measure 2.5 and 5 volts negatively and positively. It can also measure current value. From there, if you like, you are able to measure current values. This is a card that can also measure 0.20 milliampere current. We have set our voltage measurement settings from there, and from here we will use IW96 channel of the card. You see, we will use IW96 channel of this card. Let's open our program. What did we say about the value this sensor detects? If it is higher than 90 bars, my high level signal shall be lit. Now, what is the numerical value of 90 bars? Look, if 90 bar or 90% has the numerical value, that is 127,648, 90 equals to a 24,883 numerical value. In here, if it is below 10 or equal to 0, if it is smaller than 10% or 10 bars, the numerical value of it should be, if it is 100 at 27,648, what would it be at 10? Its numerical value is like 2,764. And when that happens, the low level signal shall be lit. If this value is between two values, meaning if pressure is between two values, you can think that the system is running normally. For that, I used an in-range command. You can do that with compare commands too, but in this case I preferred a range command. It was easier for me this way. Now, I have loaded my program into my PLC, and now my analog sensor detects nothing. Think of it like that. There isn't any value inside it, and my system shall start up now. I will place it under run command. Look. When I did, my Q01, meaning the low level signal, lighted up. Why? Because the pressure in the system is 0 now. Just think that you are at a power plant and we reset the pressure in the air tank. They were conducting a test or maintenance was in progress, so that's why the pressure in the tank is 0 and we received a low level signal as you have seen. We received the signal. Now, for example, we will fill this tank slowly with air. Let's say our pressure is 5 bars. What is the numerical value of 5 bars? it's something like 1382. And look, when I did that, my tank's pressure is still low, because if it is under 10 bars, low level signal is received. I will change the display settings there. Let me change them into decimal. This way I will increase my already low pressure a little bit more. Look, I am pulling air from my compressor into the system slowly. I am trying to fill the air in my compressor into here. Think of it like this. Now, let's say my pressure is 5 bar here, and as you see it slowly increased to 8 bars, which is still a low pressure, by the way. Now let's do something like this. It should rise to 12 bars or 18 bars. What is the numerical value of this? When it rises to 18 bars, your sensor, your 0,1 volt sensor will show 0 when voltage is 0. And when voltage is 10, it will show 27,648 numerical value. We have calculated the numerical number the system sends here when the pressure is at 18 bars. And we had a numerical value that is 476. And my Q01 isn't working anymore. There you see my 01 is not working anymore. Let's do something like this. My numerical number here is, let me show you like that. I will show it to you like that, for example. Let's do something like this. My numerical number here is, let me show you like that. I will show it to you like that here, as you see. I will display it like this. Yes, we displayed decimal. Look here, I have displayed it like this, and now look at my numerical number there. Look, we have made a mistake here. I will correct that. I set maximum 2764 here, but that is actually minimum. 24,888 log, that should be 2764. We have made a mistake like that here. We have made a mistake in the program. Now we will start our PLC like this. Open the glasses now and look at the pressure here. There the pressure is 18 bars, which is equal to 4,976 in terms
because
of
it is
numerical
between these two
values. The normal pressure signal is lit. We will make it 88, for example. What is the numerical value of 88 bars? It's here, 24,330. Look, our normal pressure signal is still lit. This is normal in terms of operational conditions. We will increase it to 90 bars or, for example, 94 bars. That equals to 25,989 numerical value, and when that equals to a number value like this, and of course I'm simulating through my sensor here, the temperature or the pressure here normally rises up slowly and decreases slowly. But for now, because I can't do that in the simulator, I am simulating it as if it is slowly increasing and it is getting to this number slowly. Look, here 25,989 is a numerical value that is equal to 94 bars or 94%, and what happened after? My Q2 faded, meaning my pressure level is no longer normal and my pressure is high now. This signal is on. You see, this signal. This example is done. It was a simple one, so let's continue exemplifying these analog signals.